All right, students. So in this video, we are going to go through class 9 statistics in totality. We are going to take simple data cases, simple tabular data, tables of data. And the overall focus is to understand all the objects of class 9 statistics in totality. It starts with bar chart. So let us first understand the data that we have. We have how my last Sunday went. What all did I do across 24 hours of my last Sunday? So I slept for 8 hours. I studied for 10. Well, exam time, so a little more than usual. 10 hours. Sports 3 hours, TV and all. So overall, this is how my Sunday went, 24 hours. Now what is significant, or what I would say is the highlight, call it, or what is special about this data, what is different from something else which would make some other object. Here we are talking about bar chart. So what is the significance, or how do we interpret this data? Look, every activity is independent. It is independent of the other. There's no continuity really. There's no continuity. What we mean by continuity will be evident, is explained in greater detail when we go on to the next statistics object of class 9, that is histogram and frequency polygon. So just hold on for now. We'll come to that a little later and we will explain as to what we mean by continuous data. But overall, just take it this way, that every activity is independent and there is no continuity from one to the other. So this is called non-continuous data. So whenever we have data of this kind, we represent this in pictorial form. That's what we do in statistics using the various objects like bar charts and histograms. The one that we pick to represent data of this kind is called bar chart. So we're talking about bar chart. So in this case, we have 5 activities. So those 5 activities we have represented along the x-axis. Make sure to write activities or whatever we are representing along x-axis over here. And on the y-axis, we have chosen y-axis to represent hours. So go by what we have as the maximum. 10 is the maximum. So we can well go for 1 centimeter is equal to 1 hour. So choose the scale appropriately. Here the fact that 10 is the maximum, you can well represent this data by using a scale of 1 centimeter is equal to 1 hour. And now we draw these bars. So this is what I mean by independent or non-continuous. Each activity is in silo. It is a bar. It's an island rather. It's independent of the others. That's how it goes. What is to be noted here is that the width of these bars, in bar chart does not mean anything. There is no significance to the width. However, for us to represent things consistently and so that it looks nice, we take uniform widths, and it makes sense. We take uniform widths. Well, some of these widths may not look uniform because I have used freehand drawing. You don't do it. When you are doing in a graph paper, do it carefully so that you don't bring any such inconsistency. But overall, what I'm trying to tell you is that these bars are of different heights. Yes, this represents 8 hours, this represents 10 hours, this represents 2 hours, or how much is it, 3 hours. So their heights will obviously be different, but keep the width the same. So this is bar chart. I'm going to use the same example that I took earlier. Very simple. It's a 50-mark test, mind you, a 50-mark test. And there are 50 students in a class. Yes, I hope you are clear with the data set. It's a 50-mark test and there are 50 students. So we are talking about the class interval, which is about marks. So from 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. These are the various intervals in which the students show. So the number of students, this is, let's say, 3, this is 5, this is 12, 20, then this is 10 maybe, and this is 20. So are you all good with what this data means? Don't worry what we are going to do with this data, but are you making sense with what this data is, folks? Are you able to read this data? Let me put it this way. It's a 50-mark test, and this is how the students have scored. So if you take this row, for example, it means that there are 12 students who have scored from 20 to 30. That's what it means. So this is how you interpret, right, this data. I hope everything is clear. Now, in this case, we are required to draw a histogram. So such data, which involves continuity, folks. And when I say continuity, how is it that the first data did not have continuity? We're talking about independent bars, right? Even here we will have bars, but there is continuity because from 0 to 10 we have 3 students, and from 10 to 20 we have 5. It means that there is not a single student out of 50 who will not be covered in this table. That's what it means. That's what I mean by continuity. So everyone, no matter how much you score a 0 or a 50 or a 32 or a 35 or a 37 or a 43 or a 36, you would have some interval or the other in which you would show. Makes complete sense. This is why it is called continuous data. Now in this, look, please note here that in this is case of histogram or frequency polygon. So in my other class, I was telling you that when a guest or your friend comes over, you ask him, will you take tea or coffee? You don't ask him, hey, will you take tea or puri, right? So tea or coffee, they are interchangeable in the sense somebody might prefer tea as a beverage, somebody might prefer coffee as a beverage. So tea or coffee, it's like interchange. You can, for the same occasion, it's the same occasion drink, call it that way. But tea and puri are different occasion eatables, right? What I'm trying to say is this data can be represented using a histogram or a frequency polygon, meaning histogram and frequency polygon are like tea and coffee. It's the same occasion drink. Same data can be represented using a histogram or a frequency polygon. Online folks, does that make complete sense? Let us not lag behind because we don't have time. Are you absolutely clear that histogram and frequency polygon can represent the same data? Bar chart cannot. Bar chart is something else. It's puri. Bar chart is puri. But this is tea or coffee. Absolutely clear? Yes, now, in this case, what all things are our observations? Here we observe that each one has equal width, yes, and there is data continuity. When I say data continuity, it means there could have been 0 to 9, then 10 to 19, 20 to 29, in which case there would have been no continuity. But here there is no such problem. We have equal width and data continuity. And we are now talking about histogram. We'll talk about making a frequency polygon out of this same data a little later, but now we are talking histogram. So when we have equal width and data continuity, we no need for any other column. You may like to note these things down, folks. No need for any other column. This is all that we need to make a histogram. We don't need any further columns or column. And let's see how to use this data to make a histogram. So in this case, let us write this as marks. So the class interval is marks, you will agree. And this is number of students. So in this case, scale, how will it go, folks? What do you think x-axis scale can look like? 1 centimeter is equal to 10 marks. Can we say that? Yes. And y-axis, look here, the maximum number is 20. So we can probably take 2, 4, 6. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Are we all good so far? No surprises. And here it's easy. 0 to 10, 20, 30, 40, 50. Perfect. 40, 30, 20, 10, 0. And now this is simple, right? No complications or no complexities here. 0 to 10 is 3. So this will come as 10 to 20 is 5. 20 to 30 is 12. And then I have 10. And then I have 20. Are we all good? Make sure that these things don't come inside the box. But are we all good? This is good, I would say. This is how we make a histogram. So this was a case when the widths were equal, mind you. There is another case, histogram, a second case, case 2, where the widths are not going to be the same. But here, every interval has equal width. Every class interval. I hope you are making notes of these things, folks. Every class interval has equal width. In this case, how much is it? 10 minus 0 or 20 minus 10. This is the class width. So class width is 10. This is all you need to know about the second thing. So in all, there are 4 or 5 things that we are going to study. The first one was bar chart, which we are done with. The second one is histogram with equal width and data continuity. Let me know if you have any questions in this or something that you don't agree with. I will explain, and then once you confirm, I'll do the next one. Second one, the third one that I'm going to talk about is frequency polygon with the same data. So I just told you, I could have kept it. Okay, fine. So let me erase this. Now we are talking about a frequency polygon with the same data. So I told you, right, this is a case of tea and coffee. You can serve tea or coffee interchangeably. So this data can be represented using a histogram, which we just saw. And we can also represent this data using a frequency polygon, which we are going to. So we are talking about a frequency polygon now, a frequency polygon with equal class intervals or equal width, equal width class interval and continuous data. It's the same data, right? So we already saw that the data is continuous and every class is 10 units wide. So in this case, we add a column, and that is called the class mark. We add a separate column, and that's called class mark. What will be the class mark, folks? It is the average of these two. 0 plus 10 by 2, 5. 10 plus 20, this will be 15. 25, 35, 45. Now, no one is going to ask you what this data is, but just get this right. How to interpret. There are 3 students in the 0 to 10 range. Somebody might have scored 1, somebody might have scored 9, somebody could have scored 3, somebody could have scored 4. So anything from 0 to 10, right? So instead of these, we are taking the average. So we are assuming that every person is scoring 5. That's what this means. Class mark is like averaging out that particular class interval. So let's consider this. There are 12 students who are in the 20 to 30 range. So by writing this 25, we are presuming that every student is scoring 25 in this class interval. Makes sense? So now we are good to, I'm not going to write scale and all, okay? Just let me know if you have any confusion. So again, in this case, we have the number of students here. And we have the class mark in this case, mind you. Class mark. And let us represent this on the x-axis. So we have 5. And this is 10. So let me do it a little carefully. 5, otherwise I'll run out of space. This is 5, 10. So this is 15, 25, 35, 45, Very, very important, folks. I'm going to tell you something very important. People miss out on this. So just pay attention. This is class mark, and this is number of students. I've already written number of students here. And what will work? 20. So I think I can take 2, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is 20. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, we are good. So in this case, what do we do? There are two things that we do here. The first one is easy. The class mark 5 has number of students 3. So 5 corresponds to 3. Making sense, everyone? 15 corresponds to 5. 15 corresponds to 5. 25 corresponds to 12. 35 corresponds to 10. And 45 corresponds to 20. So let me join all of these points and we'll see how it looks. This is our frequency polygon, not completed yet. Now, what is going to be the previous class mark, folks? What is going to be the previous class mark?
Minus 5.
Minus something, right?
Minus
so we would have
-5, sir.
we would -5, right? So mark that. That is how we do it. -5. And what is going to be the one after 45? It is going to be 55.
Minus.
I'm
Okay,
circling
55,
this.
55.
55. I'm circling this. You don't have to circle. I'm circling this only to highlight that these are some extra things that we are required to do when it's a frequency polygon. All you need to now do is join this and this. Our frequency polygon is ready. This is our frequency polygon for the same data for which we've earlier drew a histogram. So are you good with the third case we have been talking about? Equal width and continuous data, and how to represent that data using a frequency polygon, which we saw now, and histogram, which we saw a while earlier. Let me know if we are absolutely good with these two. With this, we have completed 3 out of 5 objects. We have 2 more objects left. Let me know once you're done.
Excuse me, sir.
Yes, Shreyas.
Sir, can we not take 0 to 10 and 10 to 20 as 1 and 3 and 5 as 8?
ये अपने मन से क्यों करोगे, Shreyas? You will be given the data, no? Why would you have to do that? No, don't do that. Shreyas is asking, shall we club this? Why would you club that, yaar? They will give you the question, no? They will give you that question. You only have to do what is given. Don't manufacture, don't add additional things to the question. That way, if they ask you acceleration due to gravity, you will say, sir, can I write gravitational constant for that? ऐसे नहीं होता ना, जो पूछा है वही करोगे ना. Yes, are we good, folks? Are we absolutely good so far? Okay, so now comes the fourth object. Again, a histogram. Histogram, the second type. Yes, Nathan?
Sir, for this frequency polygon also should we write the scale?
Yeah, absolutely, we should.
Okay, sir.
So now it is something like this, okay? We saw that there were like only 3 students in the first and 5 in the second. So this is not our problem. What I'm only saying is, what is the significance? I'm just telling you the behind the scene activity so you're able to relate. Sometimes if you are having 4 suitcases, just hear what I'm saying. Don't think too much beyond, you will miss it. If you have 4 luggages, you are traveling and you think that the first and the fourth luggage they're only half filled. Making sense? These 2 are only half filled. So don't you consider clubbing these 2 together? You would move the content of one luggage from one to the next, and instead of 4, you now have only 3 luggages. Have you made sense of this stupid thing, everyone? You are able to relate, yes? So in this case, we had a 0 to 10 and a 10 to 20 interval, and we had very few students in those 2 groups. So the data might come as something like this: 0 to 20 has 8. This is exactly the same data, folks. This total is still 50, exactly the same data, but instead of that, you might be given a data like this. Instead of that, you might be given a data table like this, and you are now required to draw a histogram. So here, look what highlights. There is continuity, continuous data, yes, continuous data, and they are of unequal width, folks. When I say unequal width, even if one interval is different from the rest, then it comes under unequal width histogram. It's possible that there were more such clubbings, but here we are talking about a simple case so that we understand the topic. We are talking about the fourth case now. So are you good with the expectations, folks? That we are talking about a histogram pictorially representing this data in a histogram where the class interval is not all equal. Hey, are we making sense? Everyone. I am not hearing a lot of yes or no. Are we all making sense?
Yes, sir.
Yes, sir.
Okay. So in this case, what we do is, if there is a road blockage, we do something, right? We either return home, which is about leaving the question, bad thing to do, or we take some turn and we take some other route. So here there is a slight difference in the way we tackle this. So in this case, what we do is we add two columns. We add two columns, folks. One width and the second length, and see what I am doing here. Pay attention, folks, and ask me questions the moment you miss out. So in this case, what I do is I'm adding two new columns. The reason I've drawn a new line is so that I'm trying to highlight. So here in this case, we add a new column called width and a new column called length. Width is going to be 20 minus 0. The upper limit minus the lower limit gives us the width. So don't you see that this width is 20? In this case, it is 10. In this case, it is 10. In this case, it is 10. Yes, the width is 20, 10, 10. So over here, after doing this, take the standard width as the one which is least wide. I hope I'm not confusing you. Least wide. So these are our standard widths. In this column, whatever the least width is, see, this can be interpreted in various ways, but I suggest that we don't do anything else now. Just pay attention to me and do it this way. So what did we do? What did we say? Take the standard width as the one which is the least. Least are the ones which have not changed. Okay. So in this case, now the formula to find the length is number of students is frequency. I hope you know this, right? Frequency is what it is called. Now, what is in this case, our standard width is how much, folks? Standard width is equal to 10. So the formula that we use to find the length is frequency into standard width by current width. Standard width by current width. So this will become how much? This is equal to 8 into standard width is 10, current width is 20. So you agree that this becomes 4, 10 into 1, 10 into 2. Is that making sense, all of you? This is how much? This is 12 into 10 by 10, mind you. So it is 12. Hey, is this confusing or are you all making sense? I hope you can see this part of the board, everyone. Can you tell me how much this comes to? This is 10 into 10 by 10. So this is 10. This is equal to 10 into 10 into, sorry, this is 20, right? This is 20. 20 into 10 by 10. So this is 20. Make sense of this column, folks. This is the key to solving the question involving histogram with unequal width. You can even see using common sense that if this width has not changed, then 12 remains 12, 10 remains 10, and 20 remains 20. But because the width has become twice, the length has become half. In this case, the width is 2 times, so the length has become half. The area overall is supposed to be equal. Take a minute and see if you are able to absorb this in totality, everyone. Ask me questions if there is any confusion.
Sir, once can you explain a formula?
Hey, it's just reverse engineering, yeah, Subrat. There is no formula as such. See, what we need to do, what I just told you is when we are calculating this width, what are the various numbers that we have? The frequency, the standard width, and the current width, right? These are the only 3 things that we have, which are going to impact. Like the volume of a cuboid, for example, is going to be impacted only by length, breadth, and height, nothing else, right? So we first determine what all are the factors impacting this formula. The frequency, the standard width, which is 10, and the current width, which is 20. So start with 8. 8 multiplied by how much will become 4? That's what we already know, yaar, in this case, that this is supposed to be the width has increased, so its length will decrease. So will it not be 10 by 20? Now just reverse engineering. Look, what is 8? 8 is 8. 10 is our standard width, and 20 is the current width. So I'm not applying any formula, folks. I'm not applying any formula. I'm just doing a reverse engineering. I already know what the answer is. And that way I'm just seeing what formula works. The reason why I'm doing this is because in the textbook and in the examples, they have done it this way. If I were to do it myself, I would not write any formula and straight away write the length. But you might lose marks that way. That's the reason why I'm insisting on the formula. But have you got the essence of what this is? When the width doubles, the length halves. If the width had become 3 times, this length would have become 1/3. These widths have not changed. They're standard width, so these things have also not changed. Are we good with this data now, folks?
Yes,
Are
sir.
we good with what all we have explained? Have you written this? I need this board space. So just make sure that you have noted. This thing will still remain, but I'm going to erase this part. So in case somebody has not written this down yet, please do it. Yes, everyone, are we good?
Yes, sir.
So this is a case. Again, I'm reiterating, folks, what I have been telling you. This is a case of unequal width. Okay. Unequal width. It's only then that we need to add these 2 columns. You saw, if you recall, that when the widths were all same, we did not have to add any columns. So in this case, how do we draw the histogram? Again, I'm not drawing a lot of things. This is class interval. So this is marks. This is number of students. So again, scale, I'm not writing it. It's easy, right? 1 centimeter, x-axis, 1 centimeter is 1 mark. And again, choose an appropriate scale. So 1 centimeter is 2 students. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Wow. 2, 4, 6, 8, 10. Aditya, kya ho gaya? Why so quiet? And marks, this is 10, 20, 30, 40, 50. Do we have Ishan or Ishan is not here? 10, 20,
I'm here, sir. I'm here.
30. You are here. Okay. तो देखते हैं. तो देखो अब क्या है, the first one is 0 to 20 and the length is 4. So now don't use this as the length, folks. This is going to be the length. This is one more thing that you can make note of. So we are going to represent this length over here. So 0 to 20 is 4. 20 to 30 is 12. 30 to 40, 10. 40 to 50, 20. Wonderful. So this is our histogram. लीजिए histogram तैयार. You can see that in this case, the widths, these three have the widths as 10. And because this width has doubled, we are not taking 8 anymore. We are taking 4. We are taking 4. This is going to be the height. Is this making sense to everyone? Suvrat, are you convinced with the formula and how we have come to the length? Everyone for that matter. Rohit, Saket,
Yes, sir.
Navika, Nipunika, everyone. Tejashwini, I don't know if Tejashwini is here. Yes, Tejashwini is here as well. Making sense. Sankalp, makes sense. Suvrat, yes.
Yes,
Vasu,
sir.
yes, tell me. Yes, go ahead. Somebody had a question.
Sir, why did you add the first two class intervals, sir?
Hey, did not add, yaar. This is given. This is a question that is given, yaar. I'm not adding anything, yeah. Just get this right. I think there is some confusion being created. This is a question that you will get. This is a question that you will get. I was only explaining the significance of a data like this. That it's possible that the widths will not be the same. In the first case, the widths were the same. And in this case, the width is not the same. You'll be given this data. You don't have to do anything. I was only explaining the significance of how this kind of data comes. This is what you will be given. This is a given data. Whatever you see here is given. And the moment you see that the widths are not all uniform, you have to add width and length columns. Makes sense?
Yes, sir.
Okay, chalo. So we are good with this. The last one is frequency polygon. So I don't see frequency polygon involving unequal width. Yes, Ankit?
Flow is not continuous.
Yeah, I will come to that. But the fifth one, frequency. So histogram can involve two kind of data, folks, equal width and unequal width. But as far as I see, even the exercise questions, for frequency polygon, you will always have equal width. That's what I see. So we don't have to discuss the frequency polygon for this scenario. Are we all good, folks?
Yes, sir.
Yes, sir.
Wonderful.
Yes,
The
sir.
last thing, and I think we should be able to wind up in another 5 minutes, is the last thing that I want to talk about statistics this term. Okay, we are in class 9, so even before the final exam, we will rediscuss this again because class 9 includes everything. That's what I presume. But this season, no more of statistics. In tomorrow's session, we are going to talk everything except statistics. So the other data can be the same data. So in this case, we had 1 to 9, 10 to 18, 19 to 27, 28 to 36. Let's say this is how the data is, okay? Let's say the last one, 37 to 45. So suppose, or maybe I can do it a little better, 1 to 10, 11 to 19, 20 to 29. What am I doing? 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. It's possible that the same data earlier, I hope you remember, we had continuity, right? We had 0 to 10, 10 to 20, 20 to 30, and so on. We had continuity in the data, right? 10 ends here and it starts from 10 again. It's like a relay race where one ends and then the next one starts. Over here, do you see a gap? There is 10 and there is 11 here. And again, you might have the number of students, 3, 5, how much was it? Just 12, 10, 20. You had like this, right? So if this data is given, folks, what we need to do is we have to make the data continuous. So continuous involves what? Subtracting 0.5 on the left hand side and adding 0.5 on this data. It's not 0.5 all the time. It depends on what kind of data we have. So we have to fill this gap so that it becomes continuous. So 1 will become 0.5 and this will become how much? 10.5, right? It's like there is 1 meter between two guys. This guy comes 0.5 meters and this guy also comes 0.5 meters and they both meet. That's the overall idea. I will repeat, my marker fell down in between, so I will just explain this to you one more time. I'm sure everyone has got it yet. So these are two guys who are 1 meter apart. This guy comes 0.5 and this guy also comes 0.5 and they are together. That's the overall idea. There was a gap of 1 between this and this. So this guy has moved towards, he has moved 0.5 meters to the right and this guy has moved 0.5 meters towards left. So this becomes 10.5. This is now 10.5 to 20.5. This will be 20.5 to 30.5, 30.5 to 40.5, 40.5 to 50.5. And in this case, the frequencies will remain the same: 3, 5, 12, 10, 20. So you now see that we have continuity, don't we? We have continuity. So now that we have continuous data, this is again good to be represented as histogram or frequency polygon. That is all, folks. Anything quick one, nothing other than statistics, please. It's very late already. We will catch up at 10 a.m. tomorrow once again for the rest of the world topics. Anything, quick question on statistics that you might have. Just one question probably. Anyone, folks? Okay, so looks like none. We are good. So what I suggest, folks, go through this recording maybe or whatever we discuss. I don't know. I don't think you have a lot of time to go through recording and everything. Go to specific parts, but try to wind up with statistics soon. I am telling you, folks, I am telling you, this is based on my experience. If you don't manage statistics properly, you will be wrapped up, entangled with statistics all day tomorrow. Try to fold this up, wrap this up as soon as you can so that you get time for the rest of the world pieces. Chalo, we'll catch up at 10 a.m. tomorrow, all of you. Good night.